Hello, everyone, and welcome back. I'm David. I'm an R Shiny developer over at Epsilon, and I will be your moderator for the remainder of today's events. Now, before we begin, I'd just like to remind everyone that you can ask questions in the chat, or you can ask in the Ask the ShinyConf speakers channel in the Shiny for All workspace on Slack. And if we have any time at the end, we will ask those questions. Now, for our next talk, I'm very pleased to introduce Joe Cheng, the current Chief Technology Officer at RStudio and the original creator of Shiny. He will be giving a talk on the new extended task feature, which will allow for intra-session concurrency. So without further ado, I'll hand over to you, Joe.
Thanks, David. I like how you called me the current CTO of Posit. Do you know something? I don't know. No, I'm sorry. Okay. Yeah, today I'm here to talk about going beyond async. And in order to talk about going beyond async, we have to start by talking about slow code. And the first thing that we should think about when we think about slow code is getting rid of it. Ideally, your Shiny app wouldn't have any slow code because all the code in it would be fast and responsive. So before we talk about async, before we talk about this new feature called ExtendedTask, if something is slow, first try making it fast. I'm not going to spend a lot of time on this today because I gave a whole talk on this in 2019 at ShinyConf called Shiny in Production, Principles, Practices, and Tools. And I gave tips like, don't guess what's making your slow app slow. Measure it with a profiler. Do as much computation as you can before the app even launches. Do aggregating in advance. Do filtering in advance if you can. And use faster file formats than CSV. Use Feather or Parquet. It's thousands of times faster to read. And if appropriate, try using the caching features that are built into Shiny. So that's the ideal. You would take your slow code and make it fast. But sometimes code is just going to be slow. Sometimes there are things that the user needs to do that are just inherently slow. Sometimes we need to call slow APIs from our Shiny apps. Maybe we need to train a large model, or you have a large dynamic R Markdown or Cordo document that you want to compile on the fly and serve to your user, and you just can't make it any faster. So in those cases, you often are going to have a problem on our hands. And to demonstrate that, I'm going to bring up this app. And to give credit where it's due, this app that I wrote builds on examples created by Virla van Leemput at this cool repo, HypeWrite Async Shiny, that has lots of examples showing different ways to deal with slow operations in Shiny. So this application lets me enter stock tickers, stock ticker symbols. And when I hit add, it will go and fetch this data from Yahoo and then do a plot of the last year's worth of closing prices. So I can add a couple of these. So in addition to VTI, let me add Microsoft and Apple. And it actually turns out that Virla's code was actually pretty fast. So I had to artificially make it a little slower. So I have an artificial delay here where it's taking 2 extra seconds to load the data. And to show how bad this problem of long-running tasks can be, let me bump that up to 10. So it'll take 10 seconds now to add the data from VTI. And while I'm doing that, while I'm waiting, I want to add, okay, Microsoft. Oh, that didn't work. It's not responding to my clicks for some reason. Oh, no, it just wasn't able to do anything because it was so busy downloading the VTI data. And now I've got all these Microsoft things. And each of these now is taking 10 seconds to load. And I'm in a bad situation. Let me just clean the slate and let me hit reload to get rid of all this. But reload doesn't seem to be working either. So we're in a pretty bad state now where I can't use the app and I can't reload it. And the reason for that is because these long-running operations, they block other users from connecting or interacting with the app, at least on that R session. That's what we call inter-session concurrency. You can't have 2 sessions that are doing things at the same time. And also, they block the user from doing other things in the same app while they're waiting. So I wanted to add Microsoft, I wanted to add Apple, and I couldn't do those things until that long download of data was done. So that's called intra-session concurrency. So both of the inability to have either kind of concurrency is a big user experience problem. In order to fix this situation, we have a new feature called ExtendedTask. We've recently rolled it out for both Shiny for R and Shiny for Python. It works very similarly in both cases. And ExtendedTask is going to fix this problem. It's going to allow us to have these long-running tasks on behalf of users while preserving both kinds of concurrency, inter and intra-session concurrency. And our goal with ExtendedTask is to have no like crazy steep learning curve to get to learn how to use it. Unlike some previous approaches we've had in Shiny, which we will address later in this talk. So let me now show you what that same application looks like with the extended task feature integrated into the code. So I'm going to change this delay again to 10 seconds, and I'm going to add this stock ticker. And this time, if I say Microsoft, it comes in immediately. I mean, the data is still going to take 10 seconds to load, but it is responsive. Let me add one more. Let's say like add Tesla. And you can see that these are happening concurrently. It's not taking 10 seconds from the finish of one for the next one to appear. It's just however long it's taking me to add each additional ticker. So this is a much, much better experience. And not only that, but while this is happening, let me add one more. Let's add Ford. While this is happening, I can hit reload and the session loads instantly. So we have achieved what we were setting out to achieve, which is both this inter-session, meaning I can hit reload and it works, and intra-session, meaning I can do other things inside of the application. Oh, in fact, I forgot to demonstrate that while this is happening, while these slow operations are happening, like I can even change other controls and have things reactively update inside of the app. So this is a very simple example, but you could imagine like a more complicated application where there's lots of things you could be doing while one particular operation is going on. So that application is a little too big for me to show the source code on a slide. So I've made this much, much smaller sort of hello world version of a slow operation. And this version on the screen now is without extended task. This is the problematic version. I've created an event reactive. So it's a reactive expression that only executes when I hit input go, when I hit the go button. And it's just going to do a sleep for a while, and then it's going to return some simple message. And because it is a reactive expression, when you want to use it in an output or something, you need to call it like a function. So this is the problematic version. When this sys.sleep is happening, we have neither inter nor intra-session concurrency. You would fix this with extended task by adding some boilerplate around your slow logic. So instead of this logic living inside of a reactive expression, it's now living in this new R6 object called an extended task. So we're going to create it with a function that is going to perform the slow task, and it's going to perform the slow task in a future. If you are not familiar with future, if you use Shiny Async, you're definitely familiar with future. But if you're not familiar with future, it's a way of taking R code and executing it in an entirely separate R process that's running in the background, so that the current R session that you're in that's running Shiny doesn't sit there completely blocked. So you create this task, and defining this task does not cause it to run. In order to cause it to run somewhere else in your app, you need to call invoke on that task. And in this case, when you hit the go button, I'm going to call invoke and pass it some arguments that it expects. And on the other side, if you want to use the output of this long-running task, if you want to use this greeting that took 5 seconds to execute, then you would call the result method. And that's all you need to do. And otherwise, your app stays the same. Just to show what this same exact example looks like in Shiny for Python, it's the same concepts, just ported to Python. So this is the version that is slow and problematic. It's a reactive expression, which are called reactive calcs in Python. And it is triggered by the input.go button. And it does the same thing. It sleeps for 5 seconds and then returns this value. And just like in R, you read a reactive calc by calling it like a function. And with ExtendedTask, again, the same thing. You call invoke on this thing. You call result if you want to do something with the result. And to define it, you use this Python decorator, this new Python decorator called reactive.extendedTask, and use it to wrap your long-running operation. So very similar and very simple. Now, that's actually, I could stop the talk right there, and hopefully I've helped you understand when you might need to use this functionality and some idea of the order of magnitude of difficulty it's going to be. And all the other information that you need to be successful with this feature is at these links. For Shiny for R, we have an article, and for Shiny for Python, we have an article, and they include examples and lots of explanations. So if you want to get a hold of these links, well, you can see all of these slides in the footer here. You can see the link to where these slides are published. And at the end of the slide deck and on slide 13, you'll have these links. But the ShinyConf organizers were kind enough to give me half an hour. So let's spend some time digging in, and let's talk about how we got here and how this compares to the other approaches to async that we've done in the past in Shiny. In 2017 to 2018, we introduced async programming first to R and then to Shiny, with the ultimate goal, of course, always being to get it into Shiny. And this was an incredibly, incredibly difficult technical feat, at least for me and for my team. So it's super challenging, but satisfying in a way because it was conceptually extremely elegant. And the way it worked, if you haven't used async, I don't expect this to be a particularly useful explanation. But if you have, this can be like a little bit of a refresher of what async was all about. So number one, as we said earlier, it relies on this future package that was not written by us. It was written by Henrik, oh, I spelled his name wrong, Henrik Bengtsson, to perform long-running operations in background R processes. So that takes care of how you launch these tasks and get them to run. And then we created a new promises package that was inspired by JavaScript promise objects to handle the results of these long-running operations in a principled way, in a way that we could integrate into Shiny. And then we had to completely rewrite Shiny's internals in order to deal with these promises. Everywhere a value is expected from the user, we expected either a normal value or a promise, and had to make all the plumbing work in both modes simultaneously. So extremely technically challenging, but very satisfying to take these two pretty different programming paradigms of promise-oriented programming and reactive programming, and to have them integrated so tightly was very satisfying. What was not satisfying was sort of the feature in terms of what it meant for users. Number one, the learning curve on this thing was incredibly steep, incredibly. I mean, I never, ever claimed that this was an easy thing to use. I always prefaced every talk about Shiny Async by saying this is a very advanced feature, and you really should only use it if you have to. And part of the reason for that is because async operations have this property that they infect everything downstream of them. Any code that returns a promise, any code that is an async function itself, it causes any downstream code to become async as well, to become promise-oriented. And that is just a really crazy property, but it's true of all async programming paradigms that I'm aware of. There's this famous essay called "What Color is Your Function" by Bob Nystrom that wasn't written about R or Shiny, but was written about async programming in general, and how it has this very viral property, not in a good way. And finally, it didn't solve the problem of intra-session concurrency at all. All it did was solve inter-session concurrency. And people noticed right when we shipped async for Shiny, this person reported, hey, this async stuff it doesn't help unblock Shiny apps within the user session, and had this really well-written example about what he wanted and why it wasn't working right. And it got 32 upvotes, which in the world of Shiny issues, that's a lot. This isn't even a Shiny issue. It's on the promises repo. 32 upvotes is a lot. I'm not sure why 2 people were celebrating, but regardless, I responded with, yeah, I'm aware. Unfortunately, this is by design. This is just kind of how this works. And then I was like, you really, really have to have this. Here's this ugly workaround that has a bunch of drawbacks and it's pretty fragile, but you can if you want to. And this got 103 thumbs up, which is unprecedented in Shiny. So clearly, this is something that people wanted to do. And after learning all this crazy Shiny async, programming stuff, you didn't even have the ability to do this thing that you wanted. So in order to talk about why this is and how we got past it, I'm going to bring in some diagrams that come from Mastering Shiny, the O'Reilly book by Hadley Wickham. This is the best source of explanation, I think, of written explanation of how reactive programming works. This is what the reactive view of Shiny is. Sorry, this is what Shiny thinks your app looks like as soon as it's loaded. It doesn't know how these different reactive pieces are related to each other. It just knows that they exist. On the left, we have reactive inputs or values. So these represent user input, widgets, and things like that. And on the right-hand side, these flag shapes, these are outputs or observers. This is code that wants to run and has some kind of side effect it wants to achieve. And in between are these reactive expressions or reactive calcs for Python. And the way Shiny works is it sees that all these things exist, and then it starts one by one picking off these flag shapes, these outputs, and starts executing them, which is what the orange means. And when the output runs, it might call a reactive expression, which then runs, so that's orange now. And these things are going to call each other. And when it's done, it's going to turn green, meaning I've done my work, I'm satisfied, I'm up to date. And this continues with the next output that Shiny finds, and pretty soon, everything's green. This is what we call a state of equilibrium, where everything reactive that wanted to run is done running. And this whole process of starting from this sort of empty, this set of gray objects with no arrows to coming to all green objects with all these arrows, that's called a tick. And what a tick means is that somewhere in the depths of the implementation of Shiny, there's a while loop that looks like this. There's not really, but conceptually. And the way it works is Shiny is going to continually wait for inputs to come from the user. When that happens, it's going to recompute all the things. It's going to do those steps that I just showed in the diagram. And when that's all done, when everything's green, it's going to send the outputs to the browser. So each trip through this loop, each iteration of the while loop is called a reactive tick. And the reason this matters is because only at the beginning of a reactive tick do we check for input changes, and only at the end do we send the outputs to the client. So while all this recomputation is happening, we can't respond to the user in any way. It brings the reactive graph to a halt. And in a case where one of these reactive expressions takes a gigantically long time to execute, we are stuck here. We are stuck, unable to listen to new changes, and we are unable to communicate existing calculated outputs to the user. And not only that, but other users are blocked. Because R is single-threaded, we can't even begin to serve another user until we exit this reactive graph. So how can we separate these two things? So what Shiny Async let you do was, if you went through all the trouble of porting your slow code to async, and all the code that needed to use the results of that slow code were all ported to async, if you went through all that trouble, you would have the ability to run multiple graphs more or less concurrently. But you can't run multiple tasks within a single graph because the graph is still working the same way. Like it's unchanged. We still have to fully process the tick, including this very large, long operation that happens to be async, before we can listen to new inputs or before we can send outputs. What ExtendedTask does is something different. It actually changes the shape here. So that reactive expression is replaced by an ExtendedTask object, which conceptually is one thing, but physically is actually two reactive components working together. On the left, we have the part that is an observer, and it causes the future to run. And on the right-hand side is a value that communicates the result to anyone who might be interested in the result. This little sleepy emoji, that's the future. So this is a background R process that when the app starts, it's just waiting. So it's taking a little nap while it waits. So when Shiny starts its reactive tick, it says, okay, this is an observer. So I am going to grab it and run it. And it might decide to kick off this feature and tell the future to get to work on this long-running task. And the future is working very hard, so it's very hot and sweaty. And other than that, the reactive graph is processed the normal way. All those steps that I showed, the same thing happens, and we get to equilibrium. As far as reactivity is concerned, we are done. We can proceed with the reactive tick. We can send outputs and go handle new inputs. So the user clicks something, and we're able to see that input, and we're able to respond to it, and we're able to send new outputs. And all this time, this poor little sweaty emoji has been sitting here sweating away, working on your background task. At some point, that little future guy is done with its work, and it communicates that by overwriting this reactive value, which is then kicks off a new reactive tick, and all the downstream values that reactively depend on the result of this extended task are going to execute the way they always do in Shiny. And now we are at true equilibrium. Not only is the reactive graph totally at equilibrium, but the extended task is done too. So there's no other work that we're waiting on. And now we are well and truly just waiting for the user to do something. So compared to Shiny Async, we now support both inter and intra-session concurrency. So I actually waited until this moment. I can go to this issue and say, this feature is now supported in Shiny thanks to ExtendedTask. Thanks for all the enthusiasm. And I can close this 6-year-old issue. So thank you for being here with me while we reach that milestone. And ExtendedTask doesn't require you to learn a strange syntax, unless you consider R6 a strange syntax, but much, much simpler than Shiny Async. And it doesn't spill its asyncness all over your code base. The kinds of changes you need to make to your code are much more targeted than they were with Shiny Async. But like Shiny Async, ExtendedTask still relies on future to put the task in the background. So, just so you're aware, there are some things that ExtendedTask does not do that you probably expect it to. Can you cancel extended tasks? Only in Python for now. You can't cancel, or at least I don't have a documented way to help you cancel tasks in Shiny for R. And neither language really has a great story for progress reporting. That is something that you could hack something together, but really deserves to be a first-class feature. With progress bars and all that stuff easily supported. In order to do that, I'm going to need some help from Future itself, some changes to Future or the alternatives to Future. And speaking of alternatives to Future, and I'm going to wrap up with this, Future is a great package, but it is not the only way that exists in the R ecosystem to run code in the background. It is very convenient. It has like a super, like I call it Automagic API, where you just put some code in Future, and no matter what variables it depends on and what functions it calls, it just seems to work. It's popular. It's been used by a lot of people, and Henrik's been supporting it for many years, so it's kind of a known quantity that's battle tested. Unfortunately, it has a high runtime overhead, and it does a lot. It is very flexible, so it has a kind of an intimidating number of options and extensions. And the implementation of that automagicness is quite complex. So sometimes it's hard to have a good mental model for what exactly is happening. There's a new package called Mirai by Charlie Gao that does some similar things to Future. It can run code in a background R process, and it works just as well as Future does for ExtendedTask. On the plus side, it's very fast. The API is easy to understand. It's pretty simple. On the con side, it's still relatively new, so it's not as battle tested, and the lack of the sort of automagic features. The API is easy to understand, but it is less convenient to use. To launch tasks, you have to do more work to set up your remote R process to get all the data and functions that it needs. There's another package called Crew by Will Landau that Virla talked about in her talk on Shiny Async last year. That it builds on Mirai, and it is more designed to launch and manage lots of tasks, multiple tasks, dozens, hundreds of tasks are totally within the wheelhouse of Crew. I've been talking to Will, and I think that it definitely works. Crew definitely works with ExtendedTask. I'm still trying to form a mental model for when you'd want to use Crew versus Future and Mirai. But he has examples in his docs, and he seems to have a pretty clear idea of how these two things fit together. So I encourage people to check that out as well. And finally, there is a Future Mirai package by Henrik, the creator of Future, that's currently in beta, that should combine the convenient API of Future with the low overhead of Mirai. I have not tried it myself, but this does seem like a pretty promising possibility. So summary, avoid long-running tasks if you can. Try to make your app fast. But if you can't, consider using ExtendedTask to run them in the background. And then here are the docs for R and for Python. And that's it for my talk. Do we have a few minutes for questions?
Yeah, we've got a couple of questions that people have asked. Firstly, thank you for that. That's definitely a feature that it solves a problem that I've encountered so many times when developing Shiny apps. Yeah, it pops up all the time. One of the questions that someone asked was, why the decision to use a sort of object-oriented approach to define these tasks and start them and get the results rather than a functional approach?
Yeah, really good question. In Shiny, we tend to use R6 objects when we want to emphasize the mutability of the thing that we're talking about, where when you call the invoke method on this object, you're not creating a new object that's been invoked. You are taking the same object that has its own identity that is now running on your behalf. So the fact that this is an object that has its own state, has its own identity, and when you call methods on it, you are interacting with that object, that one object's state, and changing it. We use R6 to emphasize that mutability, whereas a functional approach, usually that's a clue that something more immutable is happening. That if you have a data frame that you're passing into a set of dplyr functions, you are creating a new data frame each time with the result, and the old one remains untouched. So that's our reason. I don't know if that resonates with people, but on the Shiny team, that's a principle that we all kind of like.
Yeah, I think that makes sense. Is there anything, we don't have much time, so maybe just one more question. Is there anything that people should keep in mind when they're using this feature, such as, how does it behave when you start scaling to a lot of concurrent users at the same time? Is there anything that a developer should keep in mind?
Yeah, that's a great question. And that ends up weirdly being more of a question for Future and Mirai and Crew, because as far as ExtendedTask is concerned, it's just running whatever code you gave it that is going to yield a promise compatible object. And those questions about like how many worker processes are allowed and how many R processes to run on the front end, those are sort of above and below Shiny's purview. So I think Crew is especially well suited to this. My understanding is that like Crew lets you make pretty explicit policies about like how big can this pool grow and what you should do when it fills up. I'm not a crew expert, but yeah, I think extended task has very little to say about that.
Okay, that's great. All right, Joe. Well, thank you for your time. Yeah, we wish you all the best.
Great, thank you. It's a pleasure.